So everybody, welcome to the call today. Thank you for joining us. This is part of our Sustainable Electronics Tech Topics series. We're pleased today to be hearing from Adrian Beard with pinfa. He's going to be talking about flame retardants, answering the burning questions. This will be up on YouTube and on the iNEMI website at some point here in the next few weeks. Let me remind everybody that you are on mute, and if you have questions during the session, I would ask you to please type them into the chat window, and we'll gather those and ask them at the end. I will be trying to monitor it in case something people are very confused. I will interrupt Adrian to make sure that we try to deal with any big confusion that folks have. Otherwise, everything will be handled at the end of the presentation. The session is being recorded, and like I already said, it will be distributed along with the presentation itself in the next week or so from our marketing folks. I do want to let you know that we do have another session set up already for this year before you get to go away for Christmas. On December 9th, we're going to be hearing from Corey Demi from CIRI. He's going to be talking about CIRI's 2035 vision of the future of electronics sustainability, and that is up on the iNEMI website for registrations. Go to inemi.org/events, and you can find it and other webinars that are coming up in packaging and a couple of vendor projects that might be interested to many of you as well. But the next sustainability one is set up for December 9th. But you're not here to listen to me, so I'm going to stop sharing, and I'm going to turn it over to Adrian, and Adrian is going to take over and share his screen and show us all about flame retardants. So thank you, Adrian, and thanks everybody for your attention. I'll be back with you in 40 minutes or so to help address questions. Thank you.
Thank you very much, Mark, for that kind introduction, and also for the invitation to present here in the iNEMI series of webinars. And I won't be able to tell you everything about flame retardants, but hopefully some topics of interest we'll touch on. And as a pre-warning, it will be a very European perspective, especially when it comes to the regulations and the latest trends in assessing flame retardants, because a lot has happened in Europe recently. A lot is ongoing, and that's what I want to talk about today. So let's jump in. First of all, who is pinfa? So the acronym stands for Phosphorus, Inorganic and Nitrogen Flame Retards Association. So we, as an industry group, we deal with the non-halogenated flame retardant chemistries, families, and were founded in 2009 here in Europe as a sector group of the Chemical Industry Council. But by now, there are also regional groups, one in North America, founded in 2012, and one in China, founded in 2018. And we have mutual memberships with other groups like iNEMI, but also groups here in Europe that deal with fire safety aspects. And here you see an overview of the membership, around about 30 companies. And what is a bit special about pinfa is that it's not only producers of flame retardants who are members and distributors, but also downstream users like polymer compounders, polymer producers, or even we have one OEM, the company Schneider from France, who produces electric gear and electronic gear. They have also become a member because they're interested in this technology, halogen-free flame retardancy. And as a group, we have the mission to provide information on this technology, as opposed to other technologies that are out there based on, for instance, chlorinated or brominated flame retardants, and explain what is possible with phosphorus, inorganic or nitrogen flame retardants, and also exchange with other stakeholders, not only industry partners, the value chain, but also regulators and environmental groups. And as mentioned already, Europe has had many activities in the area of chemical regulation, and some of those also affecting flame retardants. So PFAS is the big topic, which is also has gained some prominence in North America and the US. So perfluorinated compounds have been a huge topic in Europe for 3-4 years now, and I've come to that briefly towards the end. But also our basic chemical law REACH is being currently under revision. Also the classification and labeling regulation. Driving all this is, amongst others, the European Chemicals Agency. You see a picture here of their institution based in Helsinki in Northern Europe. And they have issued a document, the Flame Retardants Regulatory Strategy in 2003, and this year a report on aromatic brominated flame retardants, which I'll come to in a moment. And then we have another piece of legislation here in Europe, the Eco-Design and Sustainable Products Regulation, which will deal with going forward with product groups. So eco-design regulations have been issued already or have been in existence for a while. And the concept is that regulations are issued covering a certain group of products, like air conditioners, washing machines, IT equipment, and that these pieces of regulation set requirements for recycling properties, energy use, and so forth. So the original focus was really on energy using products, but now that has been widened, and there's now an umbrella law, this regulation that's stated here, ESPR, and then subsequently pieces of regulation will be issued that again deal with certain product groups. Yeah. And this umbrella law has also introduced a new concept, that of substances of concern. You probably all have heard of substances of very high concern, which is a different thing, substance of concern. This concept relates to substances within a certain product group that are seen as potentially problematic based on either their hazard properties and what is really new in this piece of legislation, also their recycling properties. Yeah. So that's something very specific and new. But what's important to keep in mind that a substance of concern is really linked to a certain product group legally. So it can be substance X can be a substance of concern in washing machines, but not in cars. Yeah, for example. Good, but coming back to REACH, so the revision of REACH has been discussed for a number of years now and has been postponed and postponed again. The latest information is that it may still come in this year, by end of this year, but that is not really certain because there are political issues and drivers here in Europe. The European Commission, when it came up with the Green Deal here in Europe, that was before we had COVID, before we had the war in Ukraine. The whole economic and political landscape has changed a lot, and the European Commission is these days more inclined to being more business and industry friendly again, because the environment has become so difficult. Yeah. But what has been discussed under this REACH revision are topics like what is called generic risk approach, that based on hazard properties alone, certain substance groups could face restrictions or limitations without the necessity to perform a real risk assessment. Registration of some types of polymers, for instance, or just to mention another one, mixture assessment factor, which aims to take into account that we, as consumers, as humans, are not only exposed to one chemical at a time, but to complex mixtures. And to account for that we are exposed to these mixes of potentially toxic chemicals, you should introduce another safety factor to take care of that. But then again, that's still being debated, not here yet. What is in place by now is the new classification and labeling hazard classes, and those also affect flame retardants, or many flame retardants. Several are affected by these new hazard classes, and they relate to endocrine disruption, where criteria have been defined, also to bioaccumulation, toxicity, and persistency, and a really new concept, mobility, which is reflected in two hazard classes, either persistent, mobile, and toxic, or very persistent and very mobile. and that relates to substances that have some ability to move around in water bodies, so have some water solubility and have little tendency to adsorb to, say, soil or suspended particles in an aqueous body like a lake, a river, or groundwater. And PFAS is one good example. Firefighting foams, these fluorinated substances which have some water solubility and limited ability to absorb, or substances like melamine, which have been found in groundwater that is being used for drinking water production. That's where this all came from, and criteria have now been defined, linked to the potential to dissolve in water and also to absorb, that define these criteria. Good. Then looking at flame retardants in particular, I already mentioned at the beginning that ECHA published this regulatory strategy on flame retardants 2 years ago. And this was their related post on LinkedIn, that the finding of this review was that certain brominated flame retardants are identified as candidates for restriction. However, somewhat the good news was that several PIN flame retardants were identified as low hazard and no regulatory action needed. Yeah. And what is also a new concept here in Europe, an idea is to deal with chemicals in groups, so not treat one chemical after another by CAS number, by chemical identifier in terms of regulation, but try to handle or deal with chemicals in groups, because in the past, industry has sometimes, when a substance was banned, they came up with a substance that was slightly different. The molecule was only slightly modified, which then is, in technical terms, a different chemical, different registry, CAS number. So you'd have to start the regulatory process all over. And to avoid that, or to prevent that, the ECHA and others have suggested, let's deal with chemicals in groups and cover them with this approach that prevents industry from just moving a bit left or right from the target substance. Yeah. And so what we did as PINFA to, say, contribute to this discussion, we came up with this family tree of phosphorus-based flame retardants in this case. We said, look, this looks like how you could group flame retardants, or these phosphorus-based flame retardants, based on their chemistry. But when you look in more detail, you see that even within a group, there are outliers. There are some substances that have very different properties than the rest. And by now, also ECHA has also realized that by their approach. They have issued documents assessing groups of chemicals, including flame retardants, where they also come to the conclusion, if they look at 10 chemicals which form a group, when you just look at the chemical structure, that 1 or 2 of those may have really different properties and should be treated differently. Looking at phosphorus-based flame retardants in this flame retardant strategy report, they also have this table in there, table number 10, that identifies several groups of phosphorus-based flame retardants where they see some issues that most of them still need to be resolved or clarified. So you see topics here like PBT, VP, VB, so persistence, bioaccumulation, potential skin sensitization. So some of these phosphorus flame retardants have hazard properties, which doesn't mean that there's a risk immediately, but some have hazards. However, several groups have also been identified as so far no hazards identified and no further need for regulatory action, yeah, like the ones listed here. Then end of last year, the ECHA issued this report on aromatic brominated flame retardants, which were highlighted in this first flame retardant strategy document as there seems to be an issue, there seems to be a problem, we should look into them in more depth. And then the Commission asked them to do that, and they came out with this report, which you find on their website here, the links to the report and also annexes with detailed data. And ECHA also in this report came to the, or emphasized this conclusion, yes, there are certain products where something should be done or where there are really issues with environmental properties and profiles. And that's where we stand now. And next step is for the Commission to issue a restriction proposal, which we have not seen yet. It's expected in the coming months, possibly also even by end of this year. So something is moving here in Europe. When you look at the timeline, if that goes forward and if that takes the next steps, it has to go through certain committees within ECHA. So until we reach a hard ban, it would take several years. Yeah. Then on the topic of substances of very high concern, those are substances here in Europe that the Commission can declare based on ECHA proposals and investigations. And here the three products shown are just, say, the latest flame retardants that were affected or that were identified as substances of very high concern, which means that can lead to either a restriction of these substances, so you're not allowed to use them in certain applications, or authorization, where companies wanting to continue to use these substances individually need a permit from the authorities, so that you have to apply for a permit for an authorization to keep using the substance, and generally that also comes with a sunset date, so is limited in time. And so most recently, about 2 years ago, melamine was identified as an SVHC, and then more recently triphenyl phosphate, which is melamine as such is not so much used in electronics, but TPP is used also in electronic applications. These aryl, so-called aryl phosphates, are used in styrenic polymers, PCABS, for instance. And the problem here is that not only TPP is affected, but other aryl phosphates, similar products, often contain a large percentage of TPP as a side product of the production. So that's something that producers are currently addressing. But then on the side of brominated flame retardants, just recently the proposal came up, and Sweden, as the member state authority, suggested that this decabromodiphenyl ethane shown down here will also be identified as an SVHC, and that is a widely used brominated flame retardant in the industry, which has replaced decabromodiphenyl ether as a commonly used brominated flame retardants in many polymers. Yeah. So that may face, or is very likely to face, this SVHC listing as well. Now, looking at how can we make sure that new flame retardants we develop are more benign, have less hazards, are more environmentally compatible, and related to that is this concept of safe and sustainable by design, SSBD. That's what this stands for. A concept not only for flame retardants but for chemicals in general that the European Commission has put forward. This concept: how can we make sure that when you develop new chemicals that they are safe to use, and how can you assess these chemicals? And the Commission asked their research center, Joint Research Center, JRC, to come up with a guideline how to assess chemicals. And the concept is that you look at the whole life cycle of a product, from raw materials, of a production, of the use phase, end of life, what impacts there are on workers in this case, but also in the end application, exposure to humans, environmental impacts, that you even do a life cycle assessment. So really a full circle assessment is the idea for new chemicals that are being developed. And the Chemical Industry Association here in Europe, CEFIC, has come up also with some guidelines on this, or their own ideas how this should be done based on what JRC proposed. And as mentioned, the idea is that you not only look at the safety of the chemical itself, the hazard properties, but you also have to look at economic viability, of societal benefits, impacts, and of course environmental impacts. Yeah. What is not covered in these guidelines is of course the performance criteria, because they differ by product group, by application. And that is also a challenge that we've seen in the flame retardant industry. In some application areas, there are improved products with better environmental health profile, where the performance also under these SSBD criteria are much better. But if there is, say, the technical performance is less, or the price is significantly higher, there is limited market uptake. Yeah? So that's really a limitation. Yeah. So looking at this from the perspective of flame retardants, what is a sustainable flame retardant? Traditionally, we looked at these criteria up here, the hazards, which include beyond, say, acute toxicity, chronic toxicity, these points here, environmental behavior, persistence, bioaccumulation toxicity, the CMR criteria, carcinogenicity, mutagenicity, or reproductive tox, and as new effects, as shown earlier, endocrine effects or mobility in the environment. What is now new is to look at the life cycle as well of products, including carbon footprint. But carbon footprint is not everything. There are also relevant other product environmental footprint properties criteria. To look at the production, the value chain, look at use phase, impact on consumers, and even end of life, yeah, including recycling properties. And other aspects that are also included in this materials being used, critical meaning, not critical in the sense of being hazardous, but critical in the sense of supply, insurance of supply, or limitation, potential limitation of supply, because we rely on certain raw materials only from one country or region in the world. For flame retardants, one particular aspect is behavior in fire. Are there toxic products formed in case of fire, or more smoke formed than without flame retardant, or with a different flame retardant? And lastly, social impacts, possibly. When you look at the development of a new chemical product, the stepwise approach is generally in the chemical industry that you start with a business opportunity idea. Yeah, you identify where a new product can make sense, where there's market demand, where there's unmet needs in the market. Then you start your development, and then finally you launch your product. And in the beginning, you have a high level of uncertainty, not only towards the end performance possibly, but also towards environmental, chemical hazard properties. And the point of this slide is that within these steps, you need to refine in every step the knowledge you have in terms of the environmental and sustainability performance. Yeah. That it doesn't make sense, it's not feasible and at the very beginning to do the full assessment, like also nowadays without SSBD, you don't do full toxicity assessment of a new chemical in the first stage, where you also trying to elaborate the performance criteria and so on. Of course, you do first screening, and there are screening methodologies available, but you need to refine that as you go along, and then that will need to include in future also all these other sustainability aspects. And one example of a life cycle assessment that we had performed for one of our products at Clariant. This is a phosphonate-based flame retardant used for engineering plastics, for polyamide. In this example case, we did a full life cycle assessment, including carbon footprint analysis, and compared the phosphorus-based flame retardants with a brominated technology, so brominated polystyrene in combination with antimony trioxide, and looked at the life cycle from production of the flame retardant itself through polymer compounding, injection molding, part production, and then end of life scenario, which in this case was waste incineration. And the learning from this was that it's a lot of work. It's very challenging to get all the necessary upstream information. Not everything is available in databases that you have for these LCA assessments. So quite a challenge. And on the right-hand side, you see the results. One of the results in summary is savings of the phosphonate-based flame retardants versus the brominated with all these environmental impact criteria. But this main message here is, yes, doing such a full sustainability assessment is a lot of work and takes a lot of resources. Yeah. In this case, we published the results also in the open literature. You find a link here where you find all the details, and we also within pinfa try to motivate other producers to do the same, to be more transparent on these data and on these findings. Yes, for these SSBD approaches, I've said in the past, we need a toolbox, not a textbook, because this first guidance that JRC issued 2-3 years ago was very academic, very, say, theoretical, all the things you could do if you had unlimited people, resources. Of course, you can run many assessments and tests, but we need something more practical, yeah, as shown by this picture, in a way, generic picture. What and the authorities have done or responded in a sense is they have come up with a SSBD toolbox, which is called SSBD Toolbox. That is that you find here under this link, which and the aim is to, in the end, have a suite of software that will help you do these assessments with existing tools and models. And that is under the umbrella of this Partnership for the Assessment of Risk of Chemicals, which is a huge 800 million euro project here in Europe, running for several years. But this SSBD is only one element of it, yeah. And you can go to the website. Currently, it's not something that is like a software everyone can freely use. And my idea was when I first heard about this and heard the presentation, oh, wonderful! I have a piece of software I can throw in my chemical, my structure, and out comes the full assessment at the bottom. No, that's unfortunately not how it works by now, or until now. Yes, it has, say, a collection of these tools, and then also with them the limitation is some of them are behind paywalls or being offered by commercial companies, so they also want some remuneration for that, and that needs to be resolved. Yeah, but that's something that's ongoing that may help in future. Then coming to PFAS and flame retardants. PFAS is not a main topic for flame retardants. There are a few fluorinated flame retardants, but those are really very limited. The main use of PFAS in context of flame retardants is using Teflon as anti-drip additive in many formulations. But where do we stand on PFAS here in Europe, the PFAS restrictions? Yeah, initially the idea was to ban each and everything that would fall under this definition of perfluorinated chemical, anything that had a carbon and at least two fluorines attached or something like that. Now in the timeline where we stand, so ECHA aims to conclude its scientific opinion by end of next year. So everything is still in flow. A background document, which is the document summarizing the state of the proposal and the ideas, is now in version 14. And the other day someone said usually these documents have like 4 or 5 versions, but not 14. That also shows you that really, really complex topic, many iterations. This is also publicly available on their website. And I said for flame retardants, the main relevance is anti-drip additive in formulations. And this, most of you will know this UL94 test, where vertical flame test, where dripping of the material is a criterion. Yeah. So for keep reaching the best class V0, it must not drip, or the drips must not lead to ignition of cotton underneath. So dripping is a topic for fire tests and flammability behavior. Yes, and now at the state we're currently at, where do we stand on the restrictions and exemptions? And here, that's why I put it on top. Anti-drip agents for plastics for electronic components, there probably will be an exemption for the next 13.5 years. So some time for industry to find alternatives, which is not easy. It has been tried already in the past, but it's not really simple. So this shows you that maybe, but this is all still draft. Yes, nothing is final, but you also see that the discussion is progressing from we will ban very strictly almost everything as of next year to coming to these timelines where you see also other applications, 6.5 years, 13.5 years. No idea why they have these half years, but that's what the current text says. So a message is it's still all in flow. It looks very likely that there will be long transition periods allowing industry to adapt and find alternatives. And then my last topic, also on the technical side for flame retardants, there are increasing requirements, which is not surprising with technology progressing, new application areas like electromobility, also having specific needs or requirements. So here just a few to be mentioned. So on flammability performance, as just mentioned, UL 94, or glow wire performance, glow wire you see here, and okay, this picture fits to the description below. So glow wire performance and UL 94 V0 performance in combination is something that people are looking for, asking for. Thinner cross sections that will pass flammability tests, so going from 0.8 to 0.4 millimeters, for example. Maintaining mechanical properties despite adding 20–30% of flame retardant, so a filler to the polymer, which of course has an impact on mechanical properties, electrical properties, dielectric strength, resistivity, even at high temperatures, CTI that you see here on the right hand side, the test, comparative tracking index above 600. The official norm has a limit at 600, but people want more somehow. And recyclability to be able to use regrind up to 25% in materials, and going forward also using post-consumer recyclates. So that just to show you that also on the technical front, there's all these challenges, not only on the sustainability and environmental front. Yeah, so to conclude on these topics, I hope I was able to show you that Europe is really pursuing ambitious chemical regulations. This SSBD concept that I showed you needs a workable approach, and also discussions are still ongoing. This guideline issued here in Europe by JRC has been revised 2 times, and with each revision it became somewhat more practical and workable, and that is still not final, so still in flow. And when you look at an assessment of a chemical with this covering all these parameters and all these aspects, there will most likely be very few chemicals where you can tick all the boxes as okay. Yeah? So you will find chemicals where maybe recyclability is great, but you have this one hazard that you don't like so much, or you wouldn't want, or carbon footprint is bad, but you have excellent recyclability. So what I'm trying to say is you will need to make compromises or decisions where you take where you accept downsides but doing so in favor of positive sides that in that specific application may be more relevant. And we as PINFA, we try to be engaged in all these discussions, provide input and support to downstream users and also authorities. And in the end, what we try to do is also build trust in using flame retardants, because in many areas they have a, say, negative image with the general public. And before I come to the end, I invite you to visit our website for more information. We have a monthly newsletter, and you can sign up on the website. We have a lot of technical information. We also have a product finder where you can look for flame retardants, which flame retardants can be used in which polymer and application. Of course, that cannot be super specific to your specific requirements, but it gives you a general idea or starting point. That's the idea. And also a small advertisement for really great series of videos that our colleagues in North America compiled and put together. Videos that show certain aspects of flame retardant standards. Why do you need them? What about their environmental properties? How do you assess alternatives? And this latest one, number 10, is a summary or compilation of the previous one. So if you only want to or can watch one, I recommend number 10. And also the colleagues in North America, they have a great lunch and learn webinar sessions. Here's the next one coming up on finding alternative flame retardants. Bio-based flame retardants have been a topic. I haven't touched upon that. They are currently being researched a lot by academia. Also industry is looking into those. They often have the limitation that they chemically they're not very temperature stable, or they're susceptible to water and hydrolysis. In a nutshell, but there may be certain applications where they can work and will work. And then early December, Roger Avakian will talk about antimony trioxide replacements, and also we'll be aware that over the last 2 years, antimony trioxide has gone through huge price market fluctuations. If you're using that antimony trioxide in combination as a synergist with brominated flame retardants, that may also lead to considering moving from halogenated to a halogen-free formulation, maybe. Good. With that being said, thank you very much for your attention, and I'm ready to take any questions. Thank you.
Thanks, Adrian. There are several questions in the chat. I think I will try to unmute some folks so that they can ask. So Mike Kirschner, if you're available, I will allow your mic if you want to ask your question and comments that you had. And then we'll move to Curtis after you.
All right, thanks.
Mike, there you go. Now we can hear you. Perfect.
Yeah,
Thank you.
Thanks, Mark. Yeah, hey, Adrian, how you doing?
Hi, thanks. Nice to see you, Mike.
Likewise. That was good and interesting. I had a couple of points. Yeah. There is a fluorine-based flame retardant used in polycarbonates, in clear polycarbonates, perfluorobutane sulfonate. I'm probably butchering the name, KPFBS.
That's correct. Yes, that's absolutely correct. Yes, you're right. Yes.
Yeah, it's pretty common. But I agree that the use of PTFE is yet another significant issue. The question I had is about the detectability of phosphorus-based flame retardants. Ever since the European Commission banned halogenated flame retardants in enclosures and stands of TVs, monitors, and displays, manufacturers have gone to phosphorus-based flame retardants for those pieces, but recyclers are complaining that they can't detect the phosphorus easily. They could detect bromine because it's so much heavier. Um, and phosphorus, they can't use XRF because it's a tiny, it's a much smaller molecular element. So the question is, they don't want to recycle these large pieces of plastic because the downstream products made from them don't need flame retardants and would expose people in a way that's the flame retardants aren't designed for. So I'm wondering if there's a way, or if you guys have been working with the commission on detection methods, or if marking is really the only approach.
No, we haven't worked
Recyclers.
on. Yeah, we didn't work with the commissioner in this direction. There have been in the past several, say, initiatives or thoughts about marking polymers or products with, or to add a marker to identify which flame retardant is inside. But they haven't come to fruition, and those were research projects, yeah, to start with, yeah, and that would of course mean if you start marking flame retardant products now, they would come to end of life only say 5-10 years from now, yeah? And then reach the recyclers. It's not a quick fix, and everyone would need to adhere to that, or everyone would need to do it. Probably the better approach is try and find a method to detect the phosphorus in those products. Yeah. Yes, and bromine is a heavier atom, so that's why it's more easy to detect by X-ray, XRF. Yeah. And also you have more. You need more bromine atoms for the same efficiency. So there's also fewer phosphorus atoms in there, yeah, because the brominated flame retardants, they can contain 60-70% of bromine in the flame retardant itself, whereas typical phosphorus concentrations in phosphorus flame retardants are 10-20% around. Yeah. And that's also because chemically phosphorus, because it has 5 bonds, typically it sits in the middle of a molecule, and you have, say, carbon and other atoms around it, whereas bromine you can stick on the outside of almost any organic molecule. But yeah, that's more theoretical explanation, but that doesn't help in practice, I'm afraid. Yeah. But it's a valid point. Yeah. How can we make sure that products can be better recycled and better detectability, better ease of separation of waste streams is would be a big step forward. Yeah. Because it's not so much the technical recyclability once you have a defined clean stream, and that we have also shown in recycling studies that if you look at post-industrial waste or regrind, if you do several extrusion steps, what generally breaks down deteriorates is the polymer because of heat and mechanical stress. The glass fibers, if you have any, will deteriorate. The flame retardant most of the time stays intact. Yeah, so that's not really the issue. But the question of sorting and detecting is still a big problem.
Yeah. Okay. Thanks.
Okay. Yes, thank you very much. Curtis, let me unmute you if I can get it to do that. There you go. So Curtis, you should be able to take control of your mic and ask your question.
Yep. No, thank you. Within the industry, going back 25 years, if people who were around, they recall there was an issue with the use of inorganic phosphorus in molding compounds for ICs. And then in the 2010s, it was reintroduced for line cords and power cords, and a similar reliability issue came about. Typically, it's just that when you have moisture and currents in trying to be an insulator, it doesn't work too good. It typically breaks down. Is that still the issue? Have there been any, let's say, developments in that area, or is that still something that inorganic phosphorus cannot be used for?
Well, you're specifically referring to red phosphorus, yeah? Because
Yes,
yes, that's because there are inorganic phosphorus flame retardants like ammonium polyphosphate or even inorganic phosphonates. But the red phosphorus has this issue, and it's inherent, yeah? Red phosphorus, higher temperatures, moisture, they lead to chemical reactions. And it's also the background why red phosphorus is the only flame retardant that really burns well, yeah, because it's so reactive. Other flame retardants don't burn, but red phosphorus does burn, and that's also the only flame retardant where. And nowadays it's still commonly used. The main application is polyamide 6,6 glass fiber reinforced. And there you have to be careful. There's a sweet spot where, in terms of dosage, where you have where this reactivity leads to the flame retardant effect. But if you add too much, you will increase the flammability of the plastic. Yeah? I believe for these sensitive applications, red phosphorus is simply not a good product to use. Yeah? Use something different. Yeah? Where you don't have this.
Yeah, at the same time, organic phosphorus was introduced, and basically it got put in the same bucket, but it's being used a little bit more now from that standpoint that it doesn't have the issues that the red phosphorus had.
Yes, and also organic phosphorus is a big family of products, chemicals. So there's this phosphonate that I showed earlier with the life cycle assessment, for instance. That is a product that we see as, because it's also, in this case, same application as the red phosphorus I mentioned, polyamide. We see that as technically the more advanced, the better product, because it does not have this issue of chemical reactivity, also not the issue of phosphine generation. Phosphine is pH 3. You may remember NH3, ammonia, smells, things, pH 3, even worse, more toxic. but that is one of the reaction products of red phosphorus under higher temperatures and moisture, apart from phosphorus acids.
Okay, thank you.
You're welcome.
Thank you. Let's see, there's 2 more questions in here. Let me go. Frank first.
Yeah, just from a road mapping perspective, the question I'm always interested in is how long does it take to develop new solutions to particular challenges? For the case of flame retardants, what has been the typical timeline, let's say in years, from initial concept through to market availability? I know you have various testing phases to go through, for example, UL tests, etc. So what kind of timeline are we looking at?
I would say 7 to 10 years easily, until you have real commercial production, because first the identification of the target molecule, and then in lab testing easily 2 years. Then you may go to tests with customers and scale up another 2-3 years, and then you decide to build a plant. That may take 2 years, 2 to 3, and then you're in the range of I think 7 years is a best case. May even take longer. Yeah. So it's if you need a new asset, really a new plant. If you can do it in an existing plant, it will be faster. But I'd say anything below 5 years doesn't sound really realistic. If it's really new chemistry, a new chemical, if it's not just a modification.
Thanks.
So 5 to 10, broadly speaking. Yeah.
Okay, thank you. Bart, let me unmute you. All right, so you should have control of your mic. Bart, if you'd like to ask, you had a couple of points.
Yeah, I have 2 questions. The first one was about the substance of concern, right? You mentioned an example for different product groups that it differs for, what was it, washing machines and EV. So imagine you have an OEM working solely for the electrical industry. What would be the main challenges for such a producer, for instance, with this new way of thinking? Could you highlight the key challenges that such a company, or maybe you have another company in mind, the key challenges for short, medium term that have to be addressed by such a company? in their portfolio, right? So are
Yeah.
there challenges in their portfolio and how they deal with their business?
Yes, of course. I think it's important for OEMs to understand which chemicals are used in their products, and also understand it's very challenging. It's very difficult to have that visibility and transparency of what is used in your products, because there are long supply chains, and this transparency is lacking also for confidentiality reasons. But to identify potentially critical chemicals in there, and as said, to first of all have that knowledge. And if a chemical in an article fulfills the criteria for substance of concern, which are, as I said, a list of hazard criteria, like is it irritating, is it carcinogenic, is it ecotoxic, whatever. And this last point, does it negatively impact recycling? Does not automatically mean that there will be a restriction in this product group. Yeah, but the regulation says for substances of concern there may be only information requirements. Yeah, that they have to be disclosed, and that also helps. Say the end producer to and also the consumer to get this transparency. Yeah, so the regulation can force this transparency in a way, and says they have to be disclosed in the first step. There can also be restrictions, yeah, like we saw in the case of monitors, halogenated flame retardants in housings of monitors and displays. So that is also a possibility. But there also the regulation also foresees lower level measures, like first of all disclosure, creating transparency. I think that's the challenge, and as an OEM, yeah, to tackle the worst or the most problematic chemicals, ingredients first. But as you've seen, it's all a moving field. New developments, new criteria come up, so you can never say I'm totally fine. It may change next year, yeah, with something new being found. But the best way of staying on top is remaining informed and trying to get some transparency and visibility of what you have in your products, yeah, and what might be substances of concern for you, for you in particular. Yeah.
Yeah, but you also see a trend that more PCR, or at least company pledges they're using more PCR, right? So also the recyclers, I think it is probably a similar point that Frank mentioned, is you really need to sort very well then your applications, or you call it product groups, with the substances of concern, at least to get clean stream of those, so that you can reuse that in certain applications. So I think, but it seems like there's not really a lot of regulation yet to control the waste streams on this particular aspect then.
Yes, for some chemicals in recyclates, there are limits. Yeah, there are also prescriptive limits, but I think that again there we need to make a compromise. Yeah, we can't say these contaminants must be zero. Yeah, and come up with maybe some because zero doesn't exist technically. Come up with some very ambitious detection threshold or target threshold. No, then we will prevent most recycling activities. Yeah. So we need to come to a compromise where we say, okay, we accept a certain level of contamination because technically it can't be avoided. Of course, we should also look at what are the end applications for these products containing recyclates. If it's a car bumper and that contains some say unwanted ingredient, I wouldn't care as much as if it's, say, cooking utensils, yeah, that were mentioned earlier, or something where you have food contact or direct human contact. So these factors have to be taken into account, and yeah, you need to compromise. Yeah.
Thank you.
You're welcome.
The second question I had was SSBD versus EcoVadis. SSBD is more in detail life cycle assessment, as you discussed on the product level with the different aspects, and EcoVadis is more on the product, right? So these seem to be interlinked, but for instance, for a big polymer producing company or compounder, what would be the most effective way to increase the EcoVadis rating related to SSBD, related to FR products, right? So what could be the key things? So get rid of all brominated FRs. Is that the key thing, or are there other things you're thinking of to improve EcoVadis? Yeah.
I'm not an expert in EcoVadis rating, so I'm afraid I can't answer that, whether that is a key criterion for them, say content of brominated flame retardants, or whether they go by certain hazard criteria. I can't say, but EcoVadis is say fundamentally different from my knowledge from SSBD, in that it's say a something like a certification scheme may be different, but somewhat in that direction, that it sets certain standards for the supply chain, where you demonstrate that you fulfill certain sustainability criteria, whereas SSBD is really looking at the end product, that you have a full assessment of your end product. So that's conceptually a difference in my view.
Thank you.
Thank you. Yep. Thank you. We are at the end of the time. I will ask Adrian, do you have any last words you'd like to say?
No, thank you for your attention, also for those good questions. Yeah, I really enjoyed it, and also good discussion. And again, invite you to visit our website or stay in contact with PINFA if you have any needs, questions around flame retardants. But thanks again.
Absolutely. That was a great presentation today. Thank you for your attention, everybody that joined us. And be on the lookout for an email that'll have the presentation and the recording out to you. And if you've got any other questions or comments or things for Adrian or myself, you can email me, mark@inemi.org, and I'll either answer or pass it on to the right person. So thank you very much for your time. And thank you so much, Adrian,